Hello, this is Bobby from Copel TV Repair with a video today of Vizio VP50HDTV10A. I believe was the model, which uses power supply board YPSU-J013A. It's known under several different numbers. You can see them here. That's a plasma power supply board, old-fashioned style. Nobody makes them like that anymore. Probably not many people will benefit that video, but the owner of that board should. This is the unique mark on the board. I promised a video of the board working in a full set. I do apologize for that. We don't have that particular model here, and I want to tell anybody else who may be watching and learning from that. I'm sure I'm saying in a few others of our videos. Power supply boards are one of the few boards where you can actually test on a bench, if not with 100%, with near 100% certainty that they work fine. Most of the good ones, not all of them, especially the Samsung ones and some of the LG, the good brands, do have a little table, like the one shown here, that tells you what, basically tell you the specifications of that board if you look at it as a black box. It tells you what voltage and what current does it take on the inputs, and what voltages and what outputs, what currents it should be able to provide at the output. The outputs of the board, are different connectors, like on this one. On the right we see 2 pins for 24 volts and 2 for ground. So on this input, whenever it has to be activated, because the activation goes in several different steps, most likely too, it should be able to provide 24 volts, and if we look at that table, we should find out that for 24 volts, I don't know if you can see where it is, I'm actually looking at the board, not at the display. 5 24 volts, 1.75 amps is the second to last line here. It's the same for the others. Sometimes not all of them are specified. Sometimes, most of the time, if any is specified, it's usually all of them. Some boards require activation. That is, some boards require that particular pins on the control connector are shorted, or particular signals are passing over for the board to activate. More and more modern boards, when you turn them on, they start and activate everything on by default. Otherwise, usually you have to find the standby voltage, which is the one thing that is always on any board. That is, whenever you plug in the TV and it's in standby mode, there is still one low consumption, low power, low current voltage. It's usually 5 or 3.3 volts. It's called standby power. It's always available. Usually it's generated by the smaller of all transformers on the board, whatever the board is. In this case, it would be that one. Just by the size of it. There are exceptions to every rule and everything that I say, I guess. I'm saying which is the most common thing and what is the case on that board. Anyhow, this particular board we're testing outside of a TV because we don't have a TV that has the exact same board. The good thing about power boards is you can almost always test them without having the full-blown load, and that is because most of the time when they fail, they are reliably failing, and they just cannot provide the outputs, the voltages that they're supposed to. In all fairness, to properly test a board, one needs to also test it under load. In other words, all those output voltages have to be loaded. One has to connect them to some type of loads in order to actually achieve and confirm that the specified ratings, current ratings here, are proper. We don't normally do that when somebody sends a board to us unless we have a reason to, or unless we have to. For example, this board will not stay on. It will turn itself on automatically. Many boards do that. Some of them have to be instructed particularly to turn on. This one will turn on by itself, but it won't stay on unless the most powerful rail that those two transformers drive is loaded, unless there's current running there. Most boards don't need that. They have a number of large resistors here that do provide the minimal current that the power board needs in order to stay on by itself, but this particular board does need a load. And as you may read and find out in many other instructions, videos, etc., people usually use two big bulbs in series. We've tried that before, and after breaking a few and making mess, decided that's not our way. And we're doing with those two resistors. There are pros and cons to everything. The even better way is to have an electronic load that does all that. This is the more mobile and practically just as usable version. This is what we use. Long story short, I want to show that this board works. Those two resistors here are connected to the VS in order for the board to stay on. If it doesn't have that load, it will raise the VS voltage once it turns on to over the limit that the watchdog watches, and it will shut off with an overvoltage protection error. Well, this one doesn't signal an error. Some boards just have a blinking error, a blinking LED that provides an error code back. Anyhow, this is what it is. What I'm going to do is I'm going to connect this to power. We have this short extension here, and it's going to click, and we're going to watch the output voltage. There we go. Clicking. This is VS. VS is staying and stable at 192, which is what it's supposed to be. I just turned it off. Those are getting warm, but they can stay 30, 40, 50 seconds without a problem, which is pretty fine for testing a board. Usually on any old style plasma board, this is the highest and the most powerful output voltage in the whole board. Usually when a board is able to produce that, it is able to produce everything else. There are a few exceptions. All of the important heavy load voltages are monitored on most power supply boards, especially the older ones. The lower current ones like those, some of them are not. For example, an audio may not necessarily be watched, and I've seen boards that fail to start because the audio output is not here. So in addition to measuring VS, it is a good idea to measure the other outputs as well. And we may try to do that. What I'm going to do is I'm going to turn it on again. We see the VS. I'm disconnecting that. May have to reconnect again. Alright, and let's see what else do we have here. 5 volts standby, of course we have it, otherwise it wouldn't be turning on. 24 volts for the fan, 23, 43. 5 volts, 12 volts, 12 volts. VA, there's no way we can be missing VA at the very bottom here. 57. We have all the voltages. If you don't believe me, you can test that out of that board. In order to be 100% sure it's working fine, those need to be tested under load. We don't normally do that. This is where having either a TV or just testing them one by one is better. Since I'm filming this by myself with one hand, it wouldn't be so easy to show you how we do that, but long story short, we have another load resistor that is variable, and we use that one to test the rest of the voltages if we have reason to doubt they don't work, because 99% of the time it would be just fine. Yeah, I see I missed the 9 volts here, but they're there. Trust me, I did test them, or just test them yourself that way. What you do, if you want to test the rest of the voltages, which are usually less power and can be loaded with a resistor like this one. This is just, what is it, 10 ohm. 10 ohm resistor, you can get 15, 20 ohm, something that is, the more powerful it is, the better. So you get one end to the ground. You change the current meter to a current, you change that. You take one end of this, actually this to the ground now, and that is fine. So you want to, let's say you want to test the 24 volts. So you get one wire getting here to the 24. One end of the meter is connected to the ground. In this case it goes through this cable. I already disconnected it, sorry. to the ground of the board. And what I do in that case is I take the other probe, and if I put it on the far end, I'm going to load this 24 volts with 10 ohms, which gives me 2.4 amps of current. That might be too much for what it's designed to deliver. Let me see, for 24, I just said in the beginning, 1.75. So even if I put the two remote ends of this, it will load it a little bit too much, and it may start smoking. More likely it will hold, or it may just kick off. But you can do that for any of the other voltages. Usually when there's a problem, it can be anywhere actually. It happens rarely on any of the boards. We rarely ever have that problem. We usually find out whenever a board comes to us. If the board is working fine, we test it, bench test like that, and we don't find anything wrong with it, we usually go back to the customer and he says, no, it clicks on and off and it doesn't do anything. And then we start and load them individually and try to see how the individual output rails are working. Most of the time we don't do that because there is not a problem, or if we repair a board that has a problem, whatever it might be, blown fuse, blown capacitor here, the customer has replaced two, those were fine. If we have, and we send it back, the customer says, I still have a problem, it's a different one, before it was totally dead or whatever, but now it's. Then we go and test every individual one, and we did that for this board, and it held. Now sometimes, as with those 24, it would be too high, and most of the time they will hold. Sometimes we may need two of those or just a bigger resistor, but most of the time I use just this one. And when I need to increase the current, I don't touch, whenever the board is on, I don't touch the far end. I'm just sliding up like a meter here, and I'm watching in the meantime how the current raises. We can easily demonstrate that. Let's say if I switch to 12, now let's double check again. 12 volts to the resistor, this to the ground. This is in a meter, and this will be heating up. I'm sure it's connected again. So sorry for the shaky video. I may have to do something about it in the future. Alrighty. Turning on again. Let's make sure that we haven't killed anything. Alright. We're on. Of course now we don't have 170 something because we're measuring current. We're at the 12 volts here, so go. Let's see what happens at the far end. 12 volts. At 12 volts we have 0.7 amps. And as I said, if I start moving this and touch here, now we have more. We have 87. If I increase it further, it jumps to 1 amp. And if I move up, it goes higher and higher. At some point, it will either start smoking or usually protection will kick in and turn off. And again, the idea for 12 volts, we're supposed to get up to 12 volts. 12 volts, usually it's 1 amp. Yeah, 1 amp. You can see on that, I don't know if you can see it, but if you could, you will see for 12 volts, you should be able to hold 1 amp. You didn't hold it, I hold it for just a short while. But this is how we tested. We tested all of them. They did held. Most likely, if the TV is not starting up, the problem is simply not on that board. I would say 99.9% certainty. And the truth is, even if we put the board in the TV and it turns on and works for us, and this has happened several times, we still cannot be 100% sure that there is not an intermittent problem. And customers have a problem with that concept, and some of them said, what kind of a TV specialist are you if you can't tell me with certainty whether my board works or not? Well, the thing is, if we test it and it works for us, we know that it worked for us. We don't know whether it will work 5 minutes later or whether it did work 5 minutes earlier. There are intermittent problems. So much for this board. I have to make another video for the two sustain boards for these customers. Sorry for the long video too. The two sustain boards I can put in the TV since we do have a TV that uses them. And that's how we tested them. All right. I hope that helped. Thank you.